Hi, welcome to my video on the type of discontinuity. And this type, entertaining, is what we call point/removable. Point/removable discontinuity is when the two-sided limit exists but isn't equal to the value of the function. And let's explain that. We have the f of x equals x squared minus 1 over x plus 1. So if we look at the negative 1, so what happens is that x plus 1 equals 0. That means that x equals negative 1. So if we have a negative 1 here, we have our denominator 0, but also the negative 1 that we sub in here makes, let's explain, that's negative 1 squared is 1, 1 minus 1 is 0, negative 1 plus 1 is 0. So putting a negative 1 in here has what we call 0 over 0, and that's an indeterminate form. So when we have an indeterminate form 0 over 0, that means we have to look at a way of graphing this or finding the limit. So 0 over 0, so what we have is that we take the f of x equals x squared minus 1 over x plus 1. That means we have x squared minus 1 is x and x, plus 1 minus 1 is the difference of two squares, all over x plus 1. That's an x plus 1 there. I put that down too fast. Notice that the x plus 1 cancels out, so the f of x is reduced to x minus 1. But remember, a negative 1 made it 0 over 0. So if we do the f of negative 1 again on this reduced form, removable, what we did, we removed the factor x plus 1. So in essence, we removed the minus 1. Putting it back into the new form, when we simplified it, gives us negative 1 minus 1, which is negative 2. So what we have is that when x is negative 1, y is negative 2. So by removing the x plus 1 out of these expressions by factoring, cancellation, we are removing the point negative 1, negative 2 on this expression. So we have the f of x equals x minus 1. So that's the same as y equals x minus 1. So we have a line whose y-intercept is negative 1, which is right here. The slope is 1, which is 1 over 1, so up 1, right 1, up 1, right 1. So we have this line that's going through here, but this point, because we cancel out x plus 1, we are removing the point. When x is negative 1, y is negative 2. So this point right here, x is negative 1, y is negative 2, is not on this line. So here's the line, which is y equals x minus 1, coming down through here. So this is the line without this point. So it's removable. So this is what we call a removable discontinuity, because by removing the factor, we are taking away the point. So discontinuity. And that means that the f of x is equal to x minus 1, which is what this line is, except x is not equal to negative 1, because we removed the x plus 1, we removed the x equals negative 1. So this is the line which all these points on, except x is not negative 1. So we cannot, at a negative 1, we have a negative 2, so this point is not on this line. And to show you that, let me look at the graphing calculator and show you. I have my graphing calculator here now, and on the graphing calculator I'm going to turn it on. I'm going to put the line, and if you can see it, hopefully, the line I have typed in here is x squared minus 1 bracket divided by x plus 1. So that expression on this graphing calculator is this expression right here. So when I go back and look at it, I'm going to hit the graph button, and when I do, here's the graph. We look at the graph. So what the graph is that it's the same. This graph here has a y-intercept of -1, up 1, right 1. There's the line. But right here, if you can see it, right there, there's a hole right there. There's an empty space right there. And then that's the point. X is -1, y is -2. So this is a hole in this line that's illustrated here. And to zero in on that, I'm going to zero in on, I'm going to make this number, instead of -5, I'm going to make it -2. And I move down, I'm going to make it a 0. I'm going to move down further and make -3 is already there. And I'm going to use a -1. Now I'm going to graph it again because I'm zeroing in on it closer. And let's see what happens. Because I zeroed in on it, then you can see at this point right here, again, hopefully you can see there's a hollow right there. As this line goes along, there's the point. So this is x is -1, and this is y is -2. So when we graph y equals x minus 1, that's this whole line with all the points included. But because we omitted, canceled out x plus 1, we canceled out the point -1, -2. We removed it to make it. This is a discontinuity at this point. So hopefully that helps you understand what I'm trying to do. Let's look at another one. What about the p of x equals x cubed plus 3x squared minus 4x and x minus 1? So under this one, we have x minus 1 equals 0. That means x equals 1. We cannot have x equal to 1 because it makes the denominator 0. So if we look, we cannot have 1, so let's put 1 in and see what happens. So we get 1 cubed plus 3 times 1 squared minus 4 times 1 all over 1 minus 1. So when we simplify that, we get a 1. And 1 squared is 1 times 3 is 3. 4 times 1 is 4 minus 4. And this is a 0. And so 4 minus 4 is 0. Again, we have an indeterminate form. So I just write that down. So it's an indeterminate. It's an indeterminate form. And as a result, hopefully we can simplify it. We can remove it by, let's look at the p of x. And let's see if we can simplify this. So x cubed plus 3x squared minus 4x. I see a factor of x common, so I take it out. So it's x squared plus 3x minus 4. And this is a quadratic. X squared is x times x. The factors of I left off the 3 there, so just remind me for a second. I have the 3 here, so there's the 3. So the factors of 4 are 4 and 1 or 2 and 2. What factors of 4 give me a 3 is 4 and 1. Product is negative, sum is positive, so it has to be a positive 4 minus 1. So that expression right here becomes x outside of x plus 4x minus 1 all over x minus 1. And again, we can see that the x minus 1's cancel out, so the p of x is equal to x times x plus 4. And we cancel out the x minus 1, so that means we're removing what happens? We're omitting the 1. So what happens to the p of 1? It's 1, 1 plus 4. That's 1 times 5, which gives us 5. So we have a point when x is 1, y is 5. So this point, because we cancel out x minus 1, we are removing the point 1 comma 5. So let's look at the p of x is equal to x times x plus 4. So that's, if I expand that further, that's x squared plus 4x. So because, notice that this is a parabola, and the vertex of this parabola, the x-intercepts, if you let x times x plus 4 equals 0, x is 0, or x plus 4 equals 0. So x is 0 and a negative 4. So when you let the p of x equals 0, then you're getting the x-intercepts. So the x-intercepts are at 0, which is right here, and a negative 4, which is right here. So halfway between the negative 4 and 0 is a negative 2. So x is negative 2. So the p of negative 2 is negative 2 times negative 2 plus 4. I'm subbing the p of negative 2 in here. Negative 2 times 2 is negative 4. So halfway between the negative 4 and the 0 is the x-coordinate of the vertex, the axis of symmetry. So at negative 2, I have negative 4. So that's the point. Negative 2, negative 4. That's the vertex of your parabola. So negative 2 gives me a negative 4. So I have a parabola that's, again, that's positive. So it opens upward. So it's doing, I got to be careful now. I got to make sure it contains the point 1 comma 5. Because 1, put a 1 in here, I'll get 5. So the 1, 5 is right here. So the parabola goes, there's the vertex coming up through the x-intercept of 0, coming on up through, and it's going over this way, like this. There it is. But at the point 1, 5, the point 1, 5 is not a part of this parabola because we canceled out x minus 1, we canceled out the 1 comma 5 when we evaluated right here. So there's the parabola moving on, but this point is omitted. This point is not in this parabola. So that's why it's removable. So that means, again, we have what we call a removable discontinuity. If I can spell it correctly, hopefully I can. There's a removable discontinuity. That means the p of x is equal to x times x plus 4, but x cannot be 1. So we get all the points on this parabola, but we cannot have a 1. We can have all the points, but we can't have a 1. That means we cannot have the point 1 comma 5. So that's why it's a point of discontinuity or removable discontinuity, because we remove this common factor. So that's two examples to explain the point, what we call the point or removable discontinuity. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.